All right, so here is our last video, rational and quadratic inequalities. And what we do to solve inequalities is we basically find all of the zeros or all of the x values that would either be x-intercepts or vertical asymptotes. And we put them on a number line and just test the intervals in between those numbers to see if the graph would be above the x-axis at that point or below the x-axis in that interval. Okay, so here's our steps and our strategy, I guess, if we're solving inequalities. We want to write the inequality in the form p of x is less than 0 or p of x over q of x is less than 0. Now, this symbol could be anything, right? It could be less than, it could be greater than, it could be less than or equal to, it could be greater than or equal to, but it's just showing us that we want to get all of the terms on one side so that we have 0 on the other. Okay, if we're dealing with a rational expression, we want to make sure everything's on one side and that it's written as one term. Okay, and then 0's on the other side. Okay, then we want to find all, or we want to factor the numerator and the denominator completely so that we can find those zeros and those points that give us asymptotes. Okay, so we determine the zeros by, after we've factored it by just solving, and then we plot these zeros on our number line like I talked about a minute ago. And then what we're going to do is we're just going to test the intervals in between all those x values to see if they're positive or negative. We're going to shade our answer and then write our solution in interval notation. Okay, so a couple things to note, which I'm just going to write up here at the top of the page. If we are dealing with a less than or equal to symbol, this means that we want, or we are looking for, the negative intervals. Okay, we are looking for or wanting the negative intervals. Okay, because we're going to get stuff that's less than 0, right? It'll be written like this. If we see a greater than or a greater than equal to symbol, that means that we want those intervals where our function is going to be above the x-axis. So that means we want the positive intervals. Okay? And then remember with our symbols, since we're going to be graphing it, we're going to be writing our answer in interval notation. With interval notation, we either use parentheses or brackets. And the way that we determine whether we're using parentheses or brackets is based on the symbols we're given. If it is a strict inequality, that means we're not including those actual x values, those intercepts and things like that. So we would use parentheses. Okay? If we see the less than or equal to or the greater than or equal to, because it has this equal to bar, then that means we are using brackets. Okay, so this is kind of our little key, our little quick reference for doing these. Okay, all right, so let's go ahead and look at one. First one I want to look at is this one. Solve the inequality, express your solution set in interval notation. Okay, before I even get started, I'm looking at this symbol. Notice it's a greater than or equal to, which means that I want the positive intervals. So I'm going to write here, want positives. Okay, and because it has that equal to bar there, that means that we're going to be using brackets. We're including our zeros and our x-intercepts. Okay, all right, so now we just need to know, what are those zeros? What are those x values that we're going to be testing in between? Well, this one's already all on one side so that it's zeros isolated on the other, and it's already been factored for us. So all we have to do is set each of these equal to 0 and solve. So when I solve this first one, x equals 0, that's it, right? That's one of my zeros. Then I look at this next one, I have x minus 1 equals 0. Well, when I solve that, I'm going to get x equals positive 1. So that's my next 0. When I solve this one, I have x minus 2 equals 0. When I move my 2 over, I'll get x equals positive 2, right? And then this last one, when I solve it, 2x plus 1 equals 0. I move my 1 to the other side, which makes it negative. And then I divide off my 2. So I get x equals negative 1/2. So I have 4 different zeros that I am testing on this problem, right? I have 0, I have 1, I have 2, and I have negative 1/2. So I'm going to write them up here on this number line, and I'm going to strategically line them up right above these lines, and you'll see why in a second. So negative 1/2 is the first one, then I have 0, then I have 1, then I have 2. Okay, so these are all my x-intercepts. So what I'm going to be doing is testing in between each of these to see if when I draw my function, like if it touches, crosses, whatever, I want to know, are my y values above the x-axis or are they below? Okay, so I'm going to test these intervals. So I'm just going to write out what the interval is. So any number I pick in this interval has to be between negative infinity and negative 1/2, right? And notice this tells us we're using brackets because of the symbol, so I'm going to go ahead and put brackets on here. And then anything that falls in this interval between negative 1/2 and 0 has to be between, obviously, negative 1/2 and 0, also with brackets. Same thing moving over. So then I go from 0 to 1, I go from 1 to 2, and I go from 2 to infinity, okay? So notice I'm using brackets on all of them because that's what my symbol implies, except for my infinities, right? We always use parentheses on infinities because it cannot equal infinity, as infinity is not actually a number. All right, so now that we know all these intervals that we need to test, I'm just going to pick a test point. So something smaller than negative 1/2, I'm going to pick negative 1. Something between negative 1/2 and 0 would be like negative 1/4. Something between 0 and 1, I could pick 1/2. Something between 1 and 2 could be 1.5, right? Or 1.5, however you want to write it. And something bigger than 2, I'm just going to pick 3. So now that I have all my test points, what I would normally do is take these numbers and plug them back into this original, right? Plug it back into this original to see if it's going to be above or below the x-axis. But I don't actually care what it equals. So I'm not going to plug it into the whole thing. I just want to know, is it going to be positive or negative? So I'm going to write out all of my factors here. So notice I have the factor x, I have the factor x minus 1, I have x minus 2 squared, 2x plus 1, and I'm just going to write all of them there. And I'm just going to see when I plug this negative 1 in, does it make these individual factors positive or negative? Because then I can see when I multiply all those positive or negatives together, what type of sign this interval will have, if it will be above the x-axis or below. So let me show you what I mean. If I plug negative 1 in for x, I get negative 1. That's negative. Negative 1 minus 1 is negative 2. That's negative. Negative 1 in here, I get negative 1 plus 2, which is 1, and then I square it, which is going to be positive. Negative 1 times 2 is negative 2 plus 1 is negative 1. So notice I have a negative times a negative times a positive times a negative. And we know anytime we have an odd number of negatives, it's going to end up negative. So this is a negative interval, okay? And I just want to do it with all the other little intervals I'm testing. So when I plug in negative 1/4, that's negative. Negative 1/4 minus 1 is negative. Negative 1/4 inside here, negative 1/4 plus 2 is positive 1 3/4. And then when I square that, it's still going to be positive. In fact, really anything I plug in here is going to stay positive, right? Because I'm squaring it. So no matter what number I plug in here, once I square it, these should all be positive. So I'm going to go ahead and just put positives all the way across. Okay. When I plug in a negative 1/4 here, negative 1/4 times 2 is negative 1/2. Plus 1 is positive 1/2, so that's positive. Notice here I have an even number of negatives, so this is going to be a positive interval. Okay, I plug in 1/2, which is going to give me a positive. 1/2 minus 1 is negative. We already know this one's positive. And when I plug it into this last one, 1/2 times 2, or half of 2 is 1, plus 1 is 2, so that's positive. And I have an odd number of negatives, so this is going to be a negative interval. When I plug in 1.5, that's positive. 1.5 minus 1 is positive. My third factor is positive because it's squared, right? And then 1.5 times 2 is 3, plus 1 is 4. So here we have all positives, so that makes this a positive interval. And then I do the same thing for 3, which should give me positive, 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 positive. Okay, so all positives. All right, so now that we've tested our intervals and we can see that, you know, in this interval, it's going to be below the x-axis. In this interval, it's going to be above the x-axis, and so on and so forth. We go back to what our symbol implies. We had a greater than, which means we want the positive intervals. So that means this one's part of my answer, this one's part of my answer, and this one's part of my answer. So I'm just going to go up here and shade those intervals. Okay, and then I just have to check to make sure my symbols are correct. Here we have brackets on both of them because they're both included. Okay, so the first part of my answer is going to be from -1/2 over to 0. And then I have another shaded answer, so I use my union symbol. Okay, and now notice I actually shaded all the way across. I know that 1 is included, but I need to determine, because there was another 0 here, if I should break this up into 2 pieces or if I can just leave it as one shaded piece. So notice, remember, brackets mean that that 2 is included. So because it's okay for it to equal 2, I don't need to stop this and say it stops at 2 and then it starts again at 2. I can just shade all the way across. But had I had parentheses here saying that it cannot equal 2, then I would have to separate this with parentheses showing that that 2 is excluded. Okay, does that make sense? But here, since 2 is included with brackets, I can just write this as one shaded area. So that's going to be from 1 all the way out to infinity. And that's my solution. Okay. All right, let's look at another one. This one was kind of our easy case because it was already all on one side and it was already factored for us. So all we have to do is identify the x's. I'm going to do one where it's not already factored for us. So we first have to factor it to find the x's to do this whole process. Okay. All right, so let's look at our next one, which is x squared minus, or sorry, not minus, is less than -x plus 90. Now remember, we want this to be everything on one side so that we just have 0 over here on this side. So I'm going to go ahead and move these guys back over to the other side. Okay, so to move this one, I'm going to have to add x. To move this one, I'm going to subtract 90. So that's going to give me x squared plus x minus 90 is less than 0. Okay, because when I move them across, their signs change. All right, so now I have everything on one side so that it's less than 0. So I'm going to stop for just a second. This less than symbol means that I want the negative intervals. Okay, I want the negatives. All right, and because it's a strict inequality, meaning it does not have that equal to bar, this time when I write my intervals out, I'm going to be using parentheses. Okay. All right, so let's go ahead and figure out where my zeros are. This has 3 terms with an x squared, so that means hopefully I can factor it using sum product. My sum would be 1 because that's my middle coefficient, and my product is my first coefficient times my last, which gives me -90. So I need something that multiplies to give me -90 that combines to +1, which would be +10 and -9. And because my leading coefficient here is a 1, I can go ahead and just use my shortcut, which tells me this factors into x plus 10 times x minus 9. Now remember, I'm solving for x, okay? So I'm not going to use this less than symbol, okay? Because I know that less than symbol just tells me I want the negatives and I'm using parentheses. But when I'm solving to see what my zeros are, just use an equal, okay? So when I solve this one, I'm going to get x equals -10. When I solve this one, I'm going to get x equals 9. Okay, don't write this as x is less than -10, x is less than -9. Not the same thing. This is just finding the zeros. So I'm going to go ahead and plot my zeros up here. So -10 and 9. And then write the intervals on either side and in between those zeros. So the first one's going to be from -infinity to -10 with a parenthesis because we're using parentheses here, right? And then -10 to 9 with parentheses, and then 9 to infinity. Now notice here I have a couple of extra columns. That's just because I pretty much use the same table on all these problems. So these are just extra, so I'm just going to mark those out. We don't need them. Okay. All right, so let's pick some test points. A number smaller than -10 would be like -11. Something between -10 and 9, I'm going to pick 0. And something bigger than 9, I'm just going to pick 10. Okay, and then I need to put my factors here. Okay, so notice when I factored this, this factored into x plus 10 and x minus 9. So that's what I'm going to be plugging these numbers into. So negative 11 plus 10 is going to be negative. Negative 11 minus 9 is going to be negative. And an even number of negatives is going to make this a positive interval. Okay. When I plug in 0, I'm going to get a positive and then a negative. And an odd number of negatives means that this is a negative interval. And when I plug in 10, 10 plus 10 is positive, 10 minus 9 is positive, and a positive times a positive is positive. Okay. So I look back at what we wanted. We want negatives here because this is a less than. So this middle interval is my only solution. And the symbols I'm using are parentheses. So for interval notation, this would be negative 10 to 9. Okay, maybe not too bad. All right, so let's look at one that is rational. Okay, when we look at rational inequalities, we have to know the zeros from the top and also the zeros from the bottom, because the zeros from the bottom give us asymptotes, which kind of affect our graph. Okay, so notice this is already all on one side. It's all over here on the left, and zeros isolated, and it's all written as one fraction. So we're good. So what we're going to do is go ahead and look at our symbol here. It's a less than or equal to. So this means that I want the negative intervals because it's less than, and I'm going to be using brackets. Now, when I say I'm going to be using brackets, we have a little special rule for when we're dealing with rational functions, because there's an issue. When we include brackets, that means that that zero, that x value that causes it to be 0, is included. Okay? Now, it's okay to get a 0 on the top of a fraction, so we sure can use brackets up here when we find the zeros of the top. But when I solve for the zeros of the denominator, what I'm finding are x values that if I plug them back in will give me a 0 in the denominator. And that's undefined. We can't have a 0 in the denominator. So anytime you have a rational inequality, the zeros that you find from the bottom, regardless of the symbol, we will always use parentheses on. Okay? So I'm going to go ahead and break this up into the numerator and the denominator. I'm going to look at the top first. The top is 2x squared minus 18x. And I'm going to solve that. I'm going to set it equal to 0 so I can find the zeros from just the top. So here I have an x squared, which makes me think I need to factor, but I don't have a constant term, so I can't do sum product. And this is not a difference of squares. So the only thing I can hope to do is take out a greatest common factor, which in this case is a 2x. That's going to leave me with x minus 9. And now I can set each of these equal to 0 and solve. So when I set this one equal to 0, I'm going to get x equals 0. When I set this one equal to 0, I'm going to get x equals positive 9. And because these two zeros came from the top, then I can use brackets on them. So I'm just going to put a big set of brackets here to remind me these are okay to use brackets with. Okay. Then I'm going to look at the denominator. I'm just going to write bottom here. And the thing I have on the bottom is an x squared minus 2x plus 1. And I want to set that equal to 0 so that I can go ahead and solve it. I'm going to factor it using sum product. So my sum is negative 2. My product is a 1. And I can factor this using a negative 1 times a negative 1, right? Because negative 1 times negative 1 gives me positive 1, and negative 1 minus 1 gives me negative 2. And then using the shortcut, I know this factors into x minus 1 times x minus 1, right? Or we can write it as x minus 1 squared. Okay, so when I solve this, I end up with x equals positive 1. And remember, it came from the bottom. If it comes from the bottom, we cannot allow x to ever equal 1 because it would cause our denominator to be 0. So instead of using brackets on the denominator, we're going to use parentheses for this one. Okay, so let's go ahead and write out our numbers. Our smallest 0 is 0, and then 1, and then 9. So when we write out our intervals, we want to make sure to use the correct symbols on each 0. So we're going to start from negative infinity up to 0. 0 came from the top, so we can use brackets. Again, brackets at 0 over to 1, which came from the bottom, so we have to use a parenthesis on 1. Again, parenthesis on 1 over to 9. 9 came from the top, so we can use brackets. And then 9 on out to infinity. So I have one extra little column here that I don't need. Right? So let's go ahead and pick some test points. Something smaller than 0, I'm going to pick -1. Something between 0 and 1, I'm going to pick a half. Something between 1 and 9, I'll pick 2. And something larger than 9, I will pick 10. Okay? And then we need to plug them into all the factors. So notice the factors that I got from the top when I factored it was a 2x and an x minus 9, right? And what I got from the bottom when I factored it was an x minus 1 and an x minus 1. And I only have one line here. So instead of writing those out separately, I'm just going to go ahead and write this as x minus 1 squared. Okay. All right, so now we just need to test these. When I plug in a -1, -1 times 2 is negative, -1 minus 9 is negative, and -1 minus 1 is -2, but when I square it, makes it a +4. So again, because I have the squared quantity, it doesn't matter what I plug in, once I square it, it should be positive. So I'm going to go and put positives all the way across. Okay. Notice this one has an even number of negatives, so this is going to end up being a positive interval. When I plug in positive half, half of 2 is positive, a half minus 9 is negative, and 2 positives and a negative make this a negative interval. When I plug in a positive 2, 2 times 2 is positive, 2 minus 9 is negative, and 2 positives and a negative make this a negative interval. And when I plug in 10, 10 times 2 is positive, 10 minus 9 is positive, and an all positive makes this a positive interval. Okay, so I look back, we want the negatives, so that means these two intervals are the only two that came out negative, so from 0 to 1 and 1 to 9. And then I just want to check my symbols. 0 has a bracket, 9 has a bracket, and then I just have to decide, is it okay to list this as just 0 to 9, or do I have to break it up at 1? And notice here, I have to break it up at 1 because 1 is not included. 1 has parentheses. We're saying it cannot equal 1. So we can't just shade all the way across. We have to take 1 out using parentheses. Okay, so this is what my graph would look like. And then as interval notation, we would say 0 with a bracket over to 1 with a parenthesis, and then 1 with a parenthesis over to 9 with a bracket. Okay. All right. I have one more that I want to do to show you, and then I will let you work on some. Okay, so you'll notice on this one, we have another rational expression, but it's not all on one side with a 0 over here. So that's going to be my first action step here, is to go ahead and move this term to the other side. Now notice this term is positive over here, so to move it, we're just going to subtract. So we have 4x that was already over there, and then we have the minus 16 over x plus 3 when we subtract it. Okay, so now you can see everything's on this side. So we can see our symbol now. We want a less than or equal to 0. So this tells me that we want the negatives. Okay, we want the negatives, and because it has that including equal to bar, we are going to use brackets. Okay, now unlike the last one, I don't have this all in one nice little rational expression or one little fraction, right? So I need to take care of that. I need to get a common denominator so I can write this all as one numerator and one denominator. So I'm going to write this as 4x over 1, and you can see here my common denominator would be x plus 3. Right? So I'm going to go ahead and just multiply on top and bottom by x plus 3. Okay? So when I do that, the denominator of this term will now be x plus 3, which will allow me to combine the tops. Okay? So I'm going to go ahead and combine the tops, but first I have to distribute this 4x into this quantity. Okay? So 4x times x gives me the 4x squared. 4x times 3 gives me 12x, and then, 12x, and then I am subtracting the 16 from that second term because now they have the same denominators, right? So this is all going to be over x plus 3, which is less than or equal to 0. Okay. All right. So now that we have it as one rational expression, we can go ahead and find the zeros from the top and the zeros from the bottom. So I'm going to look at just the top first. So when we look at the top, the first thing I notice is, well, it has 3 terms, so I can hopefully use some product, and it has a greatest common factor. So I'm going to go ahead and factor off the 4 first. When I take a 4 out of all terms, I'll be left with x squared plus 3x minus 4. I'm setting this equal to 0 so that I can solve, right? And then inside here, we can do sum product. I need something that sums to 3 or combines to 3 that multiplies to -4, right? So this would be 4 and -1. And then because my leading coefficient is now a 1, since I took off that greatest common factor, I can use my shortcut. So this factors into that greatest common 4 that I had out there, and then we're going to have x plus 4 and x minus 1 equals 0. And then whenever I solve here, this will give me x equals -4. This will give me x equals +1, right? And these came from the top, so of course it's okay for me to have things equal 0 in the numerator. So I'm going to go ahead and use brackets for both of these numbers when I write my intervals. Okay. Then I want to look at the bottom. So when I look at the denominator, what I have in the denominator is just x plus 3. X plus 3 equals 0. I solve it, and that gives me x equals -3. So what that means is if I were to plug -3 into my denominator here, right, I would get a 0, and that's not okay. So we cannot include this, even though our symbol tells us that we want to use brackets. Because this came from the denominator, we have to use parentheses. Okay. All right, so our zeros are -4, 1, and -3. So we're going to write them in the correct order: -4, -3, and 1. And then we're going to write out our intervals. So our first interval is going to be from -infinity up to -4. -4 came from the top, so we can use a bracket. So same thing over here, -4 to -3. Now this time -3 came from the bottom, so we have to use a parenthesis. And then again with a parenthesis at -3 over to 1. 1 came from the top, so we can use a bracket. And then again a bracket at 1 on out to infinity. So I have an extra column here that I don't need. All right. So let's go ahead and put in our test points. Something smaller than -4 would be -5. Something between -4 and -3 would be -3.5 or -3.5, right? Something between -3 and 1 would be 0. Something larger than 1 would be 2. All right, and then we need to find all of our factors. So notice here when we factored the top, we had a greatest common factor of 4, an x plus 4, and an x minus 1. So notice this greatest common factor doesn't have an x, and so I pretty much save these lines for the factors that actually have an x that we can plug into. So I'm just going to attack this 4 on with this first factor. So I have 4 times x plus 4, and then I have my next quantity, which is x minus 1, and then I have my quantity from the denominator, which was x plus 3. Okay, so these are all the factors that make up the top and the bottom of this inequality. So we're going to go ahead and test now. So when I plug -5 in, -5 plus 4 is -1 times 4 is negative. -5 minus 1 is negative, and -5 plus 3 is negative. An odd number of negatives make this a negative interval. Okay. When I look at -3.5, -3.5 plus 4 is positive, times a positive 4 is positive. -3.5 minus 1 is going to be negative, and -3.5 plus 3 is going to be negative. I have an even number of negatives, so this is going to be a positive interval. When I plug in 0, 0 plus 4 is 4 times 4 gives me a positive. 0 minus 1 gives me a negative, and 0 plus 3 gives me a positive. I have an odd number of negatives, so this is a negative interval. Okay. And then I check 2. When I plug 2 in, 2 plus 4 is 6 times 4 is positive. 2 minus 1 is positive, and 2 plus 3 is positive. So all positives makes this a positive interval. So then I double check what we want. We wanted negative intervals, right? So that means the first and the third interval are the ones that I'm going to shade as my solutions. Okay, and then make sure your symbols are correct. So on this first one, we have a bracket at 4. Second interval, we have a parenthesis at -3 and a bracket at 1. So we write our interval notation for our solution. We would have -infinity to -4 with a bracket, and then -3 over to 1 with a bracket. Okay, and that is our solution. Okay, all right, so there is now 2 problems, I believe. Maybe there's 3. No, I think there's just 2. 2 problems. Nope, there's 3. 3 problems for you to try. So go ahead and pause the video and give those a whirl. And when you're ready to check yourself, unpause the video and we'll go over them. All right, so when we look at number 1, you can see here that we just go straight into the symbol. We want positives because it has the equal to bar. We're going to use brackets. When we get our 0 from the top, we should get +1/2, which we can use brackets with. On the bottom, we can factor this using sum product. So our factors are x minus 5 and x plus 1, which means we get x equals 5 and -1 as our zeros from the bottom. Because they're from the bottom, we have to use parentheses. Okay, so make sure you write out your interval notation with the correct symbols. There should be a parenthesis at 1, -1, a bracket at 1/2, and a parenthesis at 5. Okay, our factors that we put in here is the 2x minus 1 from the top and the x minus 5 and x plus 1 that we got from the bottom. Okay, when you check all of your test points, you should end up with a positive interval for the second interval and a positive interval for the fourth interval. So that is our solution that we need to write in interval notation. Okay, if you need more time to look at this, go ahead and pause the video. Otherwise, I'm going to move on to number 2. Number 2, we have a regular polynomial inequality, and notice my 45 needs to be over here on the other side. So I have my x squared, I have my 4x, and then I'm going to move that 45 over by subtracting, which will make it a -45. And because this is a greater than, that tells me I want positive intervals, and we're going to use parentheses because it's a strict inequality. Okay, this is something I can factor with sum product. My factors are x plus 9 and x minus 5, so that's what's going to go down here in my shaded rows. Okay, when I solve those, I get zeros of -9 and 5. So -9 and 5, I'm going to put on my graph here, and we're using parentheses when we state those intervals. So at -9, we have parentheses, and at 5, we have parentheses. Okay, we had a few extra columns, so we're just going to squiggle that out. And when we test our test points, our first and our last intervals should be positive, which is what we're looking for. So we state those 2 intervals with parentheses. Okay. Again, go ahead and pause it if you need more time on that. If not, we're going to go ahead and go on to number 3. Number 3 was kind of like the last example that I did, where we first need to get everything on one side and be able to write it as one term. So I moved this 9 over x plus 2 over to the other side by subtracting. So we're subtracting 9 over x plus 2. Once we get everything on one side, we can look at our symbol. It's a less than, so we want negatives, and we're going to use parentheses because it's a strict inequality. Okay. Now, in order to combine these into one term, we need a common denominator. So I went ahead and multiplied on top and bottom by x plus 2. And then I'm going to go ahead and distribute this 3x in, which gives me 3x squared plus 6x, and then minus the 9 from that other term. So now that we have it written as one nice rational expression, we want to factor the top and factor the bottom. The top, we can take out a greatest common factor of 3, and then using sum product, further factor it into x plus 3 and x minus 1. So those quantities are going to go here on my rows for the top. When I solve, that's going to give me the zeros of -3 and 1. I'm going to use parentheses on it because that's what this problem tells us to use. And then on the bottom, I have the quantity x plus 2, which will give me the 0 of -2. Again, always use parentheses on the bottom regardless of what the problem says. Okay, always. All right, so our last quantity from the bottom is x plus 2. So we write out all of our zeros. All of them should have parentheses, right? And then we test our intervals. So you can see here that our first and our third intervals, which I forgot to shade here, are our solution intervals because we want negatives, and we're going to use parentheses. So we should have a parenthesis at -3, parenthesis at -2, and a parenthesis at 1. So our interval notation looks something like this. Okay? All right, if you need more time with that, you can go back or you can pause the video to look at it a little bit longer. But that is the end of this section, which is rational and quadratic inequalities. Now, I did not really like the way that the homework was assigned in Newton. So rather than have you do a Newton assignment for this, I'm just giving you a worksheet, okay? So check your Blackboard, make sure that the worksheet is posted in there. If you don't find it, just message me, but there is not a Newton assignment for this section. Okay, there is a worksheet. So make sure you do that and you get it completed because there will be problems like this on your exam in Newton. Okay, so when you take exam 10, those of you who are in my online class, there will be problems like this on the Unit 10 exam, even though I'm only assigning a worksheet. Okay, so make sure you get that done and get it submitted, and let me know if you have any problems.